Dear friends, hearty welcome to ACE Online. Excellent program has been launched by our ACE Academy to give some information how to prepare for the GATE and Engineering Services examination. The launching program is preparation strategy for each and every subject. Today, I will be giving the preparation strategy of one subject, irrigation engineering, which comes under water resources engineering. We know it has got two parts. One is engineering hydrology, second part is irrigation engineering. I will be dealing with irrigation engineering. This preparation strategy is for both for this preparation strategy is given for both GATE and engineering services examination. One point you must remember, for GATE engineering exam, the weightage for irrigation engineering is very, very less. Sometimes they are giving for 2 marks, sometimes they are giving for 3 marks. Occasionally, they are giving even 1 mark also. If you see this GATE 2022, morning session 2 marks, evening session 3 marks, weightage is given. Last year, only 1 mark is given in one session, 2 marks is given in another session. So definitely the weightage is less compared to the other subjects like your strength of materials, geotechnical engineering, environment engineering, surveying and transportation engineering. Syllabus is equal to any one of those subjects. Syllabus is almost equal to any one of the subjects, but weightage is given, lesser weightage is given for irrigation engineering for GATE. ESE examination, compared to most of the subjects, irrigation engineering has got very good weightage. Almost 10 questions they are giving, sometimes 12 questions they are giving for ESE prelims, and mains minimum 30 marks they are giving. You can understand, for ESE examination, minimum 10 questions, very rarely 8 questions they are asking in the prelims examination, and 30-35 marks for mains. Of course, unless otherwise you get qualified in prelims, you will not be permitted to write mains examination. That's why your focus must be getting through, how to get through ESE prelims as well as GATE examination. Thus, when you see the syllabus, my dear friends, syllabus of irrigation engineering in both the exams, there is slight variation. First we give the importance to GATE, then we see in what way the syllabus differs for ESE examination. Let us see the syllabus of GATE examination. Types of irrigation systems and methods, crop water requirements, Under this, duty delta. Number 3, design of unlined canals. Number 4, gravity dams and spillways. Number 5, design of weirs on permeable foundations. Last chapter, cross drainage works. He has given in the syllabus cross drainage structures. We generally call it as cross drainage works. This was the gates. This is the gate syllabus we are having. For engineering services, how it differs, we will see. Apart from this, we got design of lined canals, extra syllabus, we will see. Additional syllabus, for engineering services examination, including both prelims and mains. Whatever syllabus is there for prelims, same syllabus is there for mains. Whatever gate syllabus, additional topics. Number 1, design of lined canals. Design of lined canals, river training works, sediment transport mechanism, and earth dams. They are giving the questions on reservoir capacity also. Generally, that syllabus will be coming under engineering hydrology, either one of the chapters. Generally, in our AS engineering hydrology, people will be covering the how to estimate the reservoir capacity and trap efficiency, etc. These 4 topics are additionally available for ESE examination, including both prelims and mains. Now, as I told you, if you are the aspirant of only gate examination, give least weightage to the subject. After making thorough with most of the subjects, at least 7-8 subjects, you can give the first or second reading for the subject. Listen the class carefully. Have the general idea about the irrigation engineering principles, because already you have studied in regular BTech course. Especially for gate examination, only 3 topics you have to give more and more concentration, because this particular program is giving the preparation strategy. 2 aspects: how to cover the syllabus in the best possible way, how to save time, saving time with maximum returns, maximum output benefit, how to get it, that is the purpose of the program. So, in the true sense, if you are really gate aspirant, you need not give that much weightage for irrigation engineering. Still, because 2 marks is not lesser, within 1 mark also your specialization may miss, your college, IIT may miss, or something else may happen. That's why subject is easier, scoring is also very easily you can score. I am telling why I am telling this statement give less weightage only because of its less importance given by paper setters in the last 30-35 years. Sometime back they used to give 5 questions, 4 questions also. Recent years only 1 or 2, 2 or 3 only. Maximum limit is 3 marks. Very rarely is giving for 1 mark. Only to give an idea, don't think that every time for all subjects same weightage will be given as it has been given in the earlier years. It is not so. It all depends on the mood, the personal interest of the group of paper setters. Anyway, we are not the people to discuss those things. Our discussion is only how to prepare in the best possible way. What is meant by best possible way? Time allotted is limited. Subject is vast. You cannot spend 15 days or 20 days for irrigation engineering out of maximum 4 or 5 months serious preparation. So please understand the most important subjects, the most important topics you can see. Water requirement of crops, very, very important subject. Design of unlined canals, design of weirs on permeable foundations. First priority, second priority, third priority we can give to the subjects. Still we have time. Gravity dams and spillways, recently they are giving on energy dissipators, spillways and energy dissipators. So you can give the fourth weightage to this. If you are really seriously preparing about the gate rank, better to read below 10 rank we are expecting. Even every 1 mark also is accountable for you. Then definitely all the 6 topics we have to prepare well. Basically, the subject of irrigation engineering is more theory oriented, less numerical oriented. Even the numericals given, except 1 or 2 instances, simplest problems they will give in irrigation engineering. Simplest problems. Example, if you see the previous questions, example, he will give the critical velocity ratio, some 0.9. He will give the depth of the flow is 1 meter. What is the critical velocity according to Kennedy's theory? Nothing is there. Simply formula substitution. Conceptual questions will be given only in few chapters, like for example cross drainage work. More concepts are needed. Design of weirs on permeable foundations also, what type of failures will happen, how to overcome those failures, etc. I repeat once again, give maximum weightage to water requirement of crops, second weightage for design of unlined canals, the 3 theories. The 3 theories, most important is Kennedy's theory and Lacey's theory. Garrett's theory is not that much important. Design of weirs is one more important area. In that we got the 3 theories, Bly, Lane and Khosla. About this you must prepare well. Prepare well. In my point, if you see this ESE examination, let me give additional 1, additional 2, additional 3, additional 4. In my view, all those 6 chapters of GATE plus A1 to A4, all 10 chapters you must make thorough. Then only you can expect very good marks from irrigation engineering. Irrigation engineering, I told you, has got maximum weightage, second maximum or third maximum of all 15 subjects you are having. maximum weightage for these examination, ESC prelims with reference to irrigation engineering. I hope you have followed this point. In the once or twice in the gate examination, lined canals concepts are asked. Concept means in which of the following situations canal will be lined. When seepage losses are found to be more, benefit cost ratio is more than 1, effective velocity is getting disturbed because of silting and scoring problem. I will give some choices like that. Just once or twice has asked what is the necessity of lining of a canal. Design of the lined canal so far not asked in gate examination. In mains ESC prelims they asked, mains examination also design problem once or twice they have asked. Anyway, you got our previous year's books, previous Q question papers books. You can prepare very well, but let me give the important concepts of each and every, in which subject, what areas you must give more weightage. Let me explain briefly about the nature of the subject. Dear friends, first most important, water requirement of crops. Water, Apisava?
From civil engineering. Their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and
So, first we are going with reference to gate point of view. For ESC, logic in the theory question will not be too much. Actually, more logical questions will be asked in gate examination. Standard methods of questions will be asked in the ESC prelims examination. Subject wise, magnitude of the problem wise, lengthy for ESC, simplest for gate. Most important for both gate and ESC, water requirements of crops. In this chapter, you must have the overall idea of irrigation procedure. We know water will be stored in the soil. When we supply some water, it will be stored in the root zone depth of the soil. To give a particular moisture content, how much depth of the water shall I provide? So, depth of the water to be stored in the root zone, to get MC, SD into MC. This much water should be available in the soil to say that the soil in the field has got a moisture content MC. If you want to change from MC1 to MC2, from the initial moisture content to the final moisture content, what depth of the water shall I deliver? So I can calculate Y from 1 to 2 status, S into D into MC2 minus MC1 is the formula we get. What is this formula? It is the depth of the water to be delivered to raise the moisture content from MC1 to MC2. You must have the overall idea, in this chapter you must have the overall idea about all the 6 moisture contents. What will happen to the crop at what moment, you must have the idea. Please recall the 6 moisture contents. Saturation capacity, most undesirable one, field capacity, OMC, TWP, PWP and UWP. 6 moisture contents are there. How much water is permanently held in the root zone depth of the soil from PWP to OMC? How much water is in the normal growth of the crop? In the normal growth of the crop, how much depth of the water will be permanently stored in the root zone depth of the soil? Answer, from PWP to OMC it will be stored. From OMC to FC, every time you are raising the moisture content in the standard way of supplying the water, implies YFC minus YOMC. YFC minus YOMC will give amount of water to be delivered by the farmer to the field every time whenever he is supplying the water. With what time gap? So depth of the water needed for this divided by everyday water consumption, that is nothing but consumed to use. Therefore, frequency of irrigation is one important parameter in the chapter water requirement of crops. Frequency of irrigation is equal to dW divided by Cu. Actually, it is not the depth of each watering only. If we provide the depth of each watering, that will be consumed within 10-15 days, that is called frequency of irrigation. So, a simple formula SD into FC minus OMC divided by Cu. We know Cu is the consumptive use of the crop. Every day plant, in order to perform all the necessary duties to have the complete growth of vegetation, how much water is required by the plant every day on the average, that is called consumptive use. What is frequency of irrigation? You must have the idea. Frequency of irrigation, time interval between one watering and the next watering. Time interval between one watering and the next watering is called frequency of irrigation. So in this particular chapter of water requirements, we study what is meant by base period, what is meant by crop period, what is meant by available moisture, what is meant by available moisture, what is meant by readily available moisture, what is meant by frequency of irrigation, what is meant by depth of each watering. I already given the formula for depth of each watering. What is the water storage capacity? It is also one important question. What is meant by water storage capacity? In total, in order to keep the plant alive, not healthy growth. Healthy growth is from OMC to FC. If you are able to supply the water, resupplying of water every time at OMC and stopping at FC, starting at OMC and stopping at FC, growth will be fantastic without any serious damage regarding the yield, quality and quantity yield. Qualitatively yield, quantitative yield will not get disturbed when you are supplying the water at OMC, stopping the water at FC. If you supply water beyond FC, it may enter into the saturation zone. It may lead to the status of water logging. You know, water logging is also there actually in this ESC prelims examination. Water logging is there, which is not there for our gate examination. In the ESC prelims and mains also, you can write that question A5, water logging and drainage. Water logging and drainage is also one chapter available in ESC prelims syllabus. In the water requirement of crops, I repeat once again, what is base period, what is crop period, what is the available moisture, readily available moisture from PWP to FC. Readily available moisture means healthy growth of the crop के लिए from OMC to FC. Frequency of irrigation. Today I supplied, next time at what date I had to supply the water externally. DW, every time what should be the depth of the water to be delivered. Once I know the volume divided by area, I can calculate the depth of the water to be delivered. I know the S specific gravity, D root zone depth of the soil, initial moisture content is OMC, final moisture content is FC. Therefore, I have written here depth of each watering is equal to SD into FC minus OMC divided by CU. On this formula, in both GATE and ESC more than 10 times, problem is asked, numerical problem is asked on in both GATE and ESC prelims examination on frequency of irrigation. And if you see, we should know what is meant by duty delta relation, what is meant by duty, area irrigated per unit discharge. If you supply water at the rate of 1 cubic throughout the base period, how much land can be irrigated? How much land can be irrigated means in how much land crop can be brought to its maturity. That is called duty of water. Duty of water, hectare per cubic, we know the units. How the duty and delta are linked. Delta is the total depth of water in the total time of base period. You can see very easily in the time of B base period, depth of the water to be delivered is delta. So delta by B is nothing but the rate of flow of water Q. Q is equal to A by D. We can get very easily. So please, a very important relation we can get between them. In SI system, delta is equal to 8.64 B by D. When delta is in centimeters, delta is equal to SI system delta I am telling. Delta is equal to 864 B by D. If delta is in feet, delta is equal to 1.98 times B by D. You must be careful about the units and their conversion factors. You must be in a position to identify. Very commonly they will ask the questions on duty, delta, base period also. Duty, delta and base period relationship. Generally, he will give SI system or CGS system of delta. When delta is in SI system, 8.64. In all these, B will be in days and the units D will be in hectare per cubic. Delta will be in meters a year, centimeters a year, very easily we can get. Also, we should know what is intensity of irrigation. Every one of us know what is meant by intensity of irrigation. So far, no question is asked in GATE examination, but chances are there to be given. GATE 2023, you may get a question on intensity of irrigation because important area so far untouched. Important area so far untouched. That's why chances are more to get, for you to get a question on intensity of irrigation. Total area irrigated in 1 year time. Total area irrigated in 1 year time by culturable command area. When I say the word 1 year, you may have 2 seasons or 3 seasons. 2 seasons, some of the areas in the 2 seasons, if the crop is irrigated, crop growth is done in all 3 seasons, monsoon, winter and summer. That is Kharif, Rabi and Zaid seasons. You can calculate some of the areas, you can keep a sigma symbol divided by CCA. expressed in percentages. Intensity of irrigation is always expressed in percentages. He may give a numerical problem, he may give a simple logical question asked. Sum of the total areas actually irrigated in 1 year span divided by area available in that catchment area which is fit for irrigation when expressed in percentage is called dash. Answer, intensity of simple concepts. If you understand the definition, then your job is over. You need not go for lengthy solutions like other subjects. It's one of the advantages of irrigation engineering. Less weightage is not actually, it has to have the more and more weightage also. At least minimum, compulsorily 3-4 questions must be given. Out of 100, minimum weightage must be 4. Easy subject, scoring for most of the students. If you just remember study the basic importance chapters, you can score very well on this. So, in this chapter, intensity of irrigation is also one important parameter. You may ask, what is the definition of time factor? You may ask, what is the definition of the capacity factor? And one more point, in ESC prelims it is asked, my dear friends, at what location, what's the name of the duty? So, names of the duty at different locations also one important parameter. Names of duty at different locations of the irrigation system is also one important point. Where do you call it as gross quantity? Where do you call it as a net quantity? Where do you call it as outlet discharge factor? Such questions are very, very important. Please concentrate much more in this water requirement of crops. In this, what are the major subtopics of importance? The 6 moisture contents, their importance. Relation between duty, delta and base period. What is meant by frequency of irrigation? What is meant by intensity of irrigation? Some names of duty at different locations also important. And one more important area here, different types of efficiencies we define in the water requirement of crops. That's also one important in the same chapter of water requirements about the water efficiencies. Please practice in the field water application efficiency. In the field water application efficiency. The definition, simple formula. At the entry of the field, 100 liters per second. Field losses are 10%. At the location of the plant, how much is that? 100 minus 10, 90 liters per second. Simple. Output by input is called efficiency. Efficiency where? That is important. That's why we said first one is in the field. In the field efficiency exclusively for the plant's growth. If you take the leaching water also, then it is called water use. Plant ke liye plus leaching ke liye. Here almost equal, but this is slightly greater because negligible water is needed for leaching. Leaching purpose nothing but making the saline soil into pure soil, making an impure soil that is filled with salt. To remove the salt, make the land refit for irrigation, we take up the leaching operation. Leaching definition is also has got some quality importance. Third one is in the canal system, water conveyance system, water conveyance efficiency, overall efficiency, water irrigation efficiency. In the field for the plant's growth, how much water you have supplied, how much water is taken by the plant. That is consumptive use efficiency, water distribution efficiency. These 6 types of efficiencies are important. Their definitions are also important. In the water requirement of crops, one more simple subtopic is there. That also should give some weightage, my dear friends. at the location of the plant, depth of the water required every day on the average called irrigation requirement. Consumptive irrigation requirement at the location of the plant per day on the average. I know delta water in B days. So at the plant, by the plant requirement is delta by B. How many times you are supplying? Maximum 6-7 times. Once एक बार supply किया तो for 15 days or 20 days I will not supply. But I imagine that throughout the season I supplied the water. That's what irrigation requirement. Consumptive irrigation requirement. Leaching water per day add किया तो NIR is equal CIR plus daily leaching. Plant के लिए daily CIR. Plant के लिए plus leaching के लिए NIR. They will ask simple qualitative definitions and you can get that very easily. At the location of the plant, FIR, at the starting point of the canal system, GIR, the formulas for efficiencies in terms of this. For example, CIR by FIR, eta A. Definition wise understand. एक बार थोड़ा सा take rough sheet and practice. Entire 12 chapters actually, that is, if you reschedule this syllabus, total 12 chapters, and you can very easily get command within 3-4 days. Not more than 4 days you devote for irrigation engineering. If you are somewhat academically already you are bright, 2 days are sufficient for the complete irrigation engineering. If you got already good knowledge, 1.5 day to 2 days is more than sufficient, dear friends. So eta A is equal, for example, eta A is equal CIR divided by FIR. Eta U is equal net irrigation requirement by FIR. Consumptive irrigation, conveyance efficiency, water conveyance efficiency is equal FIR divided by GIR. This is water conveyance efficiency. Overall efficiency eta I is equal CIR divided by GIR. Like that, we can give these definition-wise problems, definition-wise conceptual questions they will give in some other examination, of course, civil services. Which of the following is the correct relation? CIR less than, NIR less than, FIR less than, GIR. That should be the correct answer. Because unless otherwise we know the explanations, we cannot pick out the right choice, which one is right, which one is wrong. This is regarding the most important chapter, water requirement of crops. Second most important, I told you, second most important chapter, design of unlined canals. In alluvium soils. When you are designing unlined canals in non-alluvial soils, special theories are not there. Basics of fluid mechanics, basics of open channel flow are sufficient to design unlined canals in non-alluvial soils, murram, rock, gravel, etc. When silt is available, silting and scouring are the most common phenomena happening. We should get no silt, no scour condition is given by Kennedy. Constant silting, constant scouring condition is given by Lacey. That's why compared to Kennedy's theory, Lacey's theory is found to be more rational and more commonly we adopt Lacey's theory for the design of unlined canals. So regarding the design of unlined canals, you must remember that the cross section is always trapezium. Don't forget this. Side slope of the cross section is half horizontal to slope of the cross section, half horizontal to 1 vertical. Formula for area BD plus D square by 2. Formula for wetted perimeter B plus D root 5. These 4 points you must remember whether you are following Kennedy's theory or Garrett's theory or otherwise Lacey's theory. Kennedy's theory is called critical velocity theory. Critical velocity theory. Only one equation. What are the propositions made by Kennedy you must know. What are the drawbacks of Kennedy's theory? Why we are supporting Lacey as compared to Kennedy? You must have the idea. Why that fellow has not given the importance for B by D ratio. Why he has taken no silt, no cover, whereas how Lacey has justified constant silt, constant silting and constant covering. Kennedy has not given the importance for silt grade and silt charge. Lacey has given the importance. So, only one mathematical formula given by Kennedy. No formulas are available by Garrett. Garrett's is simply graphical procedure based on Kennedy's theory. In the Lacey's theory, what are the assumptions? You must practice. The flow must take place always continuously in unlimited incoherent soil, alluvium soil. Silt grade is constant, silt charge is constant, discharge is constant. Nature of the silt available at the bed, nature of the silt suspended in the suspended water, in the suspended state of the flowing water should be the same. Under those, if all these assumptions are satisfied, canal is said to be in the true regime condition. Lacey's regime theory. What is meant by true regime? What is meant by initial regime? What is meant by final regime? Of course, we got other regimes like apparent regime, permanent regime. They are not important, only 3 are important. True regime, initial regime and final regime. And those mathematical formulas of Lacey's theory also very, very important. Like V is equal to QF square by 140. I need not give the formulas, formula की जरूरत नहीं. R is equal to 2.5 V square by F and S naught is equal to F to the power of 5 by 3 by 3340 Q power 1 by 6. Using these 3 formulas, of course we got 3 more formulas. Most commonly we use these formulas once we know the silt friction factor. If silt friction factor is not given, the diameter is given, then we will follow 1.76 square root of average diameter taken in millimeters. So, please understand that the theories are important here. What is the relative comparison of Kennedy's theory and Lacey's theory? Why Lacey's regime theory is more prominent? Even though it has got some drawbacks. Why it is found to be more sound? That also you must practice. Second important chapter is design of unlined canals in alluvium soils. Please remember these points. Don't forget Kennedy's drawbacks, Lacey's drawbacks, and mathematical equation, single mathematical equation given by Kennedy and 6 mathematical equations in total given by Lacey. Apart from the fundamentals, cross section of the unlined canal in alluvial soil is always trapezium. In the non-alluvial soil it can be rectangle also. Triangle will never provide. Either we provide rectangle or trapezium. Unlined canal in non-alluvial soil can be any one of them. But in alluvium soil, only one cross section, that is shape of the cross section is trapezium. Please don't forget this point. This is regarding the second most important chapter, design of water requirement of crops thorough hone ke baad. After you become thorough with the first chapter, go for the second chapter. Give maximum weightage to the first chapter. ये भी हो गया तो then we go for the third chapter. The third important chapter is wears on permeable foundations. The next chapter we discuss. Design principles of diversion headworks. Design principles of diversion headworks on permeable foundations. Design headworks on permeable foundations. This is the third most important chapter in irrigation engineering. Third important chapter. I told you, first one is water requirement of crops. Second chapter, unlined canals. In unlined canals, Kennedy and Lacey, Garrett, they will never ask. At the maximum, they will ask Garrett's the graphical procedure is based on dash, answer, Kennedy's theory. Numerical problems on Lacey's theory are very commonly asked in both GATE and ESC prelims. ESC prelims must and should. You may ask Lacey's regimes cover depth. You may ask what is the Lacey's wetted perimeter, length of the waterway. Wetted perimeter is nothing but length of the waterway. P is equal 4.75 times root cube. Such standard relations you must practice. Just keep 5-6 papers, white papers. While you are going through the material available, write down the main points. Just have a glance once or twice. You will remember forever till you complete all your exam and get through with flying colors. In the diversion headworks, we know the examples of diversion headworks are weirs and barrages. You may ask, what is the purpose of different components? What are the components available in the layout? Components in the layout of the diversion headwork. How many canal regulation works are provided? What are the silt controlling mechanisms? What are the canal flow controlling mechanisms? What are the river flow controlling mechanisms? What type of problem will come and how do you rectify? All these, about everything about the components, their functions in the layout of the diversion headwork is important. Components of the cross section is also important. Components in the cross section of a weir. What is the difference between gravity weir and non-gravity weir? Self weight. And components in the cross section of the weir. Once has asked, as we move from left to the right, from left to right of the cross section of the weir, which of the following is the correct order of the sequence of existence of the components? Starting point, upstream side launching apron, block production, solid apron, inverted filter, downstream launching apron. In between we got piles. Cross section figure आपको mind में चहरा लगाना है. Stamp. What is the layout of the diversion headwork? What are the components that are existing in the layout, as well as here we got for the purpose of diversion, for the purpose of controlling the river flow, for the purpose of control of the flow in the canal, for the purpose of diversion from river to the canal. What component is located where and why it is located, why it has been established. Purpose is important, location is important. Designs they will never ask. They are 1 mark questions. Design principles they will ask. For example, like Ogee spillway works on the principle of works similar to the principle of dash, answer rectangular notch. Q is proportional to L, Q is proportional to H power 3 by 2. So only such logics they will ask. Design के लिए, design a weir like that they will never ask, my dear friends. Don't waste your time unnecessarily, because subject is very lengthy, vast syllabus and less weightage. Even with the compared to the amount of syllabus, number of questions in ESC prelims also only 10. That is also somewhat less. Syllabus is that much large. I am not keeping you to be away from the irrigation engineering. It's not like that. Give weightage, जितना देना चाहिए उतना ही देना है बस. ज़्यादा मत देना, completely neglect मत करना. You are busy with strength of material structure analysis RCC. 1 hour break हो गया. Just take diversion headworks, go through one's class notes, numerical problems from material, standard problems available in the PVQ, finish. Keep it aside. एक हफ्ते के बाद, 1 week later, take the notes of gravity dams, have a glance. Some points are common in strength of materials and gravity dams. Recall. Try to remember the mathematical formulas needed to solve the standard models of problem like modes of failure. I am just giving the general idea because it's the preparation strategy. What to read, what not to read. What to read with the greatest intensity, what to read with the moderate intensity, what to read with lesser intensity. Just I want to give information. Afterwards, is your choice. If you is your choice, how much time you allot, it all depends on your rate of perception of the other subjects, time available for you, the what is it called, the zeal and dedication you show for the preparation. How many times you want to get relaxed means how many times you want to read every day. 4 or 5 times with every half an hour break, or half an hour study with 2 hours break for every half an hour. Then may God bless you. So it all depends on you should prepare your own strategy. Our A's will give the concentration on only giving helping tools, some information, basic info. Compared to the previous 35 years of the papers, in what chapters more importance, in what chapter moderate importance, in what chapter least importance. What chapter को ज़्यादा importance देना चाहिए. That is the only one intention of the launching this program is launched by our management. Very useful. If you just after the components of the cross section of the weir, difference between weir and barrage is important. Failure of the weirs on permeable foundations. 90% of the questions they will ask on this. Failure of weirs on permeable foundations. Two surface failures like rupture of the floor and slowing action. Two subsurface failures, one is the uplift pressure, the other one is the piping or undermining. Regarding the 3 theories are available. How the piping failure will take place. What is the importance of Blaise creep theory? Different terminology in the Blaise creep theory. Lane's weighted creep theory. Cost loss, exit gradient theory. These are very, very important topics. Most important, components of the layout, components of the cross section, their purpose. Next most important, types of failures, surface and subsurface failures. What is the cause of the failure? How to get the protection. Cause of the failure, remedy. Cause of the failure, remedy. That is important. 4 failures and their controlling methods. You must have the good idea. And then the 3 theories regarding Blaise, Lane's and the cost loss theory. Cost loss has given almost a very exhaustive way of theory of seepage flow. Following the Laplace equation, obeying the flow net analysis. Each and every point regarding cost loss theory, once or twice kindly read. Blaise and Lane's, if they ask, they will ask a simple numerical problem. Cost loss theory, both logic and problems also important. 2 years back has asked to calculate exit gradient. 2 years before that, I think around 2016 or 2017, they asked, given the downstream pile uplift pressure percentages, has asked what is the uplift pressure percentage at the corresponding points of mirror image on the upstream pile. Given the data for the downstream pile points, calculation of the corresponding data for the upstream pile points once it is asked. How much minimum thickness shall I provide so that uplift pressure will be counteracted by self weight of the slab. That formula T minimum, factor of safety into H by SC minus 1. If it is USBR recommendation 4 by 3, IS code recommendation 3 by 2, sometimes he will give this, once he has given in the civil service examination, he has given 7 by 5, that is 1.4 he has given as the factor of safety. Simply we give the formula T minimum is equal to resist against the uplift pressure, minimum thickness of the solid apron, H divided by SC minus 1. This will be generally replaced by factor of safety. Factor of safety can be 4 by 3, 3 by 2, or in one of the examinations 7 by 5. That's why if you refer to the standard books, FOS is given, factor of safety into H upon SC minus 1. This is very, very important third chapter we are having. Let us go to the next chapter. What is the limiting height of the gravity dam? Important subtopics I am telling. When do you call a dam as a high dam? When do you call a dam as a low dam? Limiting height formula. Equate the maximum permissible compressive strength of the concrete is equal to the stress, maximum stress induced. Or with whatever mix you will get F, whatever stress you are inducing at the toe, you are equating, from that you will get the formula for limiting height, permissible compressive strength of the concrete divided by gamma water into S minus C plus 1. C is the uplift pressure coefficient, Cu is the standard symbol we use. What are the different forces? What are the different moments? How do you calculate? He has asked what is the resultant water force. He will give 60 meters on the upstream side, 6 meters on the downstream side. At what distance from the toe the resultant moment, the resultant force will act. So P1 H1 P1 Y1 bar minus P2 Y2 bar divided by P1 minus P2. Basics of engineering mechanics, basics of strength of materials we are using in the gravity dam analysis. Modes of failures. What is a sliding failure, overturning failure, compression failure, tension failure, what are the conditions, what are the factors of safety, how to get the protection, what is the minimum value we should get. Then types of stresses, how do you calculate direct stress, bending stress, normal stress, hydrostatic pressure, principal stress and shear stress. At a heel and at a toe, you must know how to calculate. The fourth topic is also very, very important topic for both GATE and ESE, more for ESE examination. In the GATE examination, gravity dams are asked only 4 or 5 times, the two with simple fundamental principles. Then one more most important area in gravity dams is elementary profile of the gravity dam. Elementary profile of the gravity dam. Why only 3 forces are acting? What are the conditions required for elementary profile? How do you fix up? Fixation of the design bed width. Fixation of the design bed width, that is greater value of, these formulas, stress criteria, safety, sliding criteria and stability criteria, H by mu into S minus C, H divided by root of S minus C formulas. Its importance you must know. In elementary profile, how much stresses are developed at toe and heel, that is also an important area. What is the importance of drainage gallery? In GATE exam is asked, in ESC exam also 3-4 times asked. Why should you provide drainage gallery? What is its extra advantage? Because of provision of drainage gallery, uplift pressure will get reduced. How to take up the repairs in the gravity dams, grouting operation, etc. What are the types of joints, longitudinal joints and transverse joints? There is both expansion and contraction joints. About the basic information should prepare. Is also one important chapter, gravity dams. In spillways, if you take up the spillways, my dear friend, Ogi spillway and siphon spillway, only these two are important. In Ogi spillway, when do you have the pressure of the flow over the crest, under atmospheric, above atmospheric or atmospheric? How do you calculate the effective length of the crest of the spillway, Ogi spillway? What is the general range of discharges for the Ogi spillway? What is the purpose of the spillway? Which of the following devices are called safety valves? Such questions are asked very commonly. So, about these two mathematical formulas also important. Other channels, other spillways only purpose. When do you go for secondary spillway? When main spillway has gone for repair. When do you go for open channel, side channel spillway? Side channel. When the heavy water is expected by means of river floods. To keep the dam safe, from upstream of the dam to the downstream of the dam, we provide a side channel so that without measurement, surplus water will be simply disposed of without getting it touching the vertical face of the dam section, providing the safety for dam against overturning. Such type of theory questions will be asked in case of spillways. What is meant by morning glory spillway? Once is asked, of course, in other exam, not in our GATE. This, and then you should practice about energy dissipators also. In case of energy dissipators, all the 5 cases you must remember. What is the need of energy dissipation? What is jump height curve? What is tailwater curve? Jump height curve is a mathematical. Tailwater curve is experimental. Their relative comparison, when they coincide with each other. When TWC lies above JHC, it is practical, it is theoretical. TWC is practical. JHC for all discharges, that is Y versus Q. So, all the 5 cases you please practice regarding the energy dissipators. Friends, these chapters are more than sufficient. Please practice well, and I repeat once again, water requirement of crops, number 1. Number 2, design of unlined canals. Number 3, design of diversion headworks is more important than gravity dams. In diversion headworks, cost loss theory is also in the recent years, they are giving more prominence for the cost loss theory questions. About 12 to 15 points have been given by cost law. And then in the gravity dams, commonly modes of failure is very important of all. Modes of failure, then forces, stresses, direct stress, bending stress, normal stress, principal stress, shear stress. These 5 types of stress are also important. In the elementary profile, fixation of the bed width is important. In these energy dissipators, you will give the match the following. Column 1, TWC coincides with JHC, above, below, partly above, for low discharges above, for high discharges below, like that you will give the options. But in the match the following, 2 times the questions are asked on these energy dissipators. River training works about spurs and groins they are asking. What is the basic difference between spur and groin? Spur is made up of temporary materials. Groins are made up of permanent materials. To extend it from one of the bank of the river into the river, either pointing upstream or pointing downstream or pointing perpendicular. Anyone, you can get it very easily done. Regarding the sediment transport mechanism, 2 theories are there. No scour condition at the bed, at the side slopes. Tau 0 less than or equal to tau c for no scouring action at the bed. 0.75 times tau 0 less than or equal to tau c into root of 1 minus sin square theta by sin square phi on the side slopes of the unlined canal. Shields theories are very important. I am telling for ESC preparation. For ESC preparation, extra topics are what are the types of earthen dams, what is meant by phreatic line, what are the possible failures of earthen dams, and what are seepage failures, structural failures, hydraulic failures. Only peripherally, please prepare your self notes. Observe keep in view always the previous year questions because of less weightage I am telling. For ESC, no excuse, no restrictions, entire syllabus, all chapters, you must be thorough. So if you see these additional questions, river training work is what is meant by meandering. In river training works, what is meant by meandering, you can ask. What is the difference between spur and groin, you can ask. What is meander ratio, what is the degree of, in gate exam is asked, what is the degree of sinusoicity, tortuosity, you can ask. Then he may ask also on the lined canals. Why the lined canals bottom edges are cornered, having curvature? To see that if you keep sharp edges, accumulation of sand will take place. It will lead to silt deposition. Effective depth will get reduced. Effective discharge may get reduced by 30-40%. What are the basic principles of design of lined canals? If you are ESC student, lined canals is also important. And water logging, rise of the groundwater table, coming close to the ground level, entry into the partially saturated zone, making it saturated, expulsion of air from the root zone depth of the soil, creating non-aerobic conditions leading to the fall of the crop yield. One of the best method, conjunctive use of water. Second best method, providing tile drains. Third best method, training must be given to the farmers. Fourth best method, you should avoid inflows into the catch fields. So, what is meant by water logging? What are the causes and effects and remedies? And most importantly, the mathematical formula on tile drain is a very important formula. One formula is Q is equal 4K into B square minus A square divided by L. Second formula DC is equal P bar into L divided by 100 into 86,400 and Q is equal DC. These are the mathematical formulas needed for water logging and drainage. Friends, these are the important topics in irrigation engineering under preparation strategy.
From E&T branch.
Thank you very much.
I took ACE postal course, mains test series and interview guidance program in ESC 2020 and ESC 2021.
Hello everyone, My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE postal course, mains test series and interview guidance program in ESC 2020 and ESC 2021.